Thank you. Yeah. Hello, everybody. So, yeah, as Tim mentioned already, it will be about click-through rates and how we can increase this, especially for those cost per clicks campaigns. So, to give you a short background of the TX group or Tamedia, as you might know it. Okay, so the TX group contains like of different pillars, and you have quite some brands below which contains to this group. Just because you might not know the TX group as a name, but you might know quite some of those brands. So the talk here, or the project we have here, was together with Goldbach Advertisement, which is one of those pillars. In addition, there is like TX Markets, which contains of the marketplaces and classifieds. Then there is the 20 minutes, which is all about commuting, media, and then the Tamedia, like, and where they're coming from the paid publishing newspaper segments. So why is Tamedia as a media publisher concerning about click-through rates and advertisement? Well, that's because like the group itself, or the network, creates 1.4 billion page impressions over the whole network per month. So there's quite a lot of space which can be filled with ads. And we have with Goldbach Advertising the network where we act as publisher, where advertisers can actually send their advertisements, and we will fill the spaces there. So the TX group campaigns, therefore, on the one hand side, we have information about the click behavior on the ads. On the other hand, we also have behavior of the customer on those different brands. And last but not least, there's also the user data which we're getting from those different brands. Advertisement and this cost per click, where we focus on this one. So of course there is programmatic, but I don't talk at all about that. If an advertiser is booking a campaign with us, then most of the time it's like display campaigns, which is still the majority, where the customer cares actually about impression, about visibility. He knows exactly who should see those impressions, so he also defines targets of the users. And on the other hand, there are those CPC campaigns where the advertiser cares about lead generation, about clicks on the ad, and he doesn't care about how often we expose the ad or to whom we show it. It's all about getting those clicks. And therefore we are quite aligned. So on the one hand, we as a publisher, we want to use as few impressions as possible to generate those clicks, because increasing there the click-through rate and having the traffic used in an efficient manner also then directly translates into revenue. So that's also the focus we have today on those cost per click campaigns, also because those campaigns haven't been optimized yet. So they're still like in the hierarchy. First of all, there's programmatic and display campaigns served, and afterwards, currently in the past, it was more or less random out of a pool of CPC campaigns which ad has been displayed to a customer without using any contextual or any other information which ad could perform best. So today I will show two approaches. The first one now, which is the one which we have implemented and which is live, and then a second one which is still work in progress, but I still want to show you some of the current insights or where we are going to. So that's a little bit the structure we currently have. So we have the user, and they might be very familiar if you are in this advertising business, but still I want to give those small little background. We have the user, we have a DMP where we have quite some information about the user, about segments he is in, and so on. Then we have AppNexus, which is our ad server, and so the user actually makes a request to AppNexus together with all the segments he has from the DMP, and then AppNexus is delivering the ad in the end and decides what is displayed on the page. Well, as I told you before, like when it already went down the ladder and AppNexus will show a CPC ad to this customer, in the past it was more or less random. And that's exactly where we wanted to kick in and say, well, we think we might know the customer better than just making something random in the end. However, with the whole approach, we are in the end limited to whatever idea we come up to. It needs to fit into this ecosystem to be actually served in the end. So our idea in this first approach was, well, as the user is sending his segment information, even though it's not used when currently the CPC campaign is selected in the end, we can get some performance statistics about, well, which segments or which ads has been exposed to which segments and how often have those people clicked on an ad. So that's what we will start. So we will actually retrieve the segment performance for the different campaigns. Then what we are estimating is like a density function of the click-through rate using Bayes inference in the end, such that we get a little bit, or we want to know, like, is this segment, does it have a higher performance than average or than other segments? And therefore we don't only care about the click-through rate as a one metric, because it really depends on how often it also has been exposed already, but we care about how sure are we that the click-through rate is better. So therefore, that's then also like what we're doing in the next steps. We are calculating this probability of being best or of being better than the average, and I'll show an example right afterwards, after this slide, with all those steps. And then in the end, we are selecting those segments which show a high probability of being better than just an average or then also like a random exposure. So as soon as we have this, we're like, we are optimizing this traffic by creating a shadow campaign, which then just lives beside the original one, but now this shadow campaign does have a targeting. Why don't we just manipulate the original campaign? I think that's quite obvious, but still, we're not doing that because as soon as we have added a target, only customers which fit into a segment will be exposed to this ad. However, if, for example, there's anonymous traffic, or even if like a customer has segments but we don't find an appropriate CPC campaign, then we still want to expose these ads, and therefore we still keep the original campaign as a backup with a little bit lower priority. And the second reason is that we can then compare the performance of the shadow campaign to the original campaign to see then also like the effects we have on the click-through rate. Now this is just one example. So we have in this ad where actually you can estimate the value of your estate. And overall the performance is like down here in blue. It has been exposed in 7 days over or nearly 1 million times, and it got like 500 clicks, which has a click-through rate of 0.049%, which is quite low, but in a general click-through rate on ads, that's what you can expect in the end. On the other hand, we have those segment performances where we have for each of the segments customers are in, we know how often it has been exposed and how often it has been clicked. And if we take, for example, this orange one, we have a segment which is called Intense Real Estate Renters, which seems to have a quite nice click-through rate. It's like 0.1%. However, you also see like number of impressions and clicks is quite low. So how can we now see or get a good feeling about, is this click-through rate now better than average? So those are the density functions which we are estimating. So we see that for average, we are quite sure that this is the real click-through rate, while for the target segment is quite broader. And this allows us now to compare those two density functions, and we can see that like the probability of this target segment is with a probability of, I think here it's like 93% probability, it is better than the average. And we have currently a threshold which is around 90%. So if we are sure 90% or more that it's better than average, we select it as a target. We recalculate those probabilities and see what happens with the numbers several times a day. So even if like in the beginning and it doesn't have that many impressions, we think this is a good candidate and we expose it and we add it in as a target, we will get more traffic from those segments, and we will then see whether it performs or not. So it's not like if a segment is in there that it's always in there, it can also then drop out later on if we just get more impressions but nobody clicks on it. So already with this first approach, which actually only cares about the performance of the segments, in the past, we observed an improvement of like 20%. So with the same amount of impressions, we get on average 20% more clicks. Also for communication of this model or what we are doing, it was quite handy because it's quite obvious and easy to interpret what we are doing. And the third point, which is also quite nice about this approach, is that it's not bounded to any AppNexus instance. We are only using data which is already in this universe and creating additional value out of it. So it can also then be like transformed or transferred to other instances. It also comes with some challenges. The first one definitely is like it heavily depends on the availability of those segments, which are currently like manually defined rules. When is a customer in which segment? And also we are a little bit limited in the sense of we cannot really say, well, this user should see the following ad. We can just say like users which are in the following segment should see following a specific campaign. And the third point also is, well, the approach only works like for all the customers for which we have segments in the DMP, which is definitely not the case for all users and for all the traffic, of course. So therefore, we want to improve this one in this like second approach, which, as I told you already, like is a work in progress. But to give you some preliminary insights on this one, or what's the idea behind it. So we do want to switch from this segment-based approach to a more like recommender approach, where we really say, well, from the data we have, which user should actually see which campaign, which then also needs some change in the infrastructure, of course. But that's like the goal. And therefore we also want to add not only information we get from the clicks itself, because as you have seen, the click-through rates are quite low. We will add information which we get from the users, from his browsing behavior and from other contexts, in order to see, well, like which users are similar and not only be dependent on the click actions we actually see on the ads. So that's a first insight into what we have done there. So we just collected like the clicks from the past 60 days. Here we care about all the campaigns, so not only on the CPC, because for learning which creatives are similar or which campaigns are similar to each other, we don't care whether it's display campaign or CPC, because also the customer cannot distinguish. He just sees ads in his browser, but he doesn't see what kind of ad it is in the end. And then we analyzed here we separated like the German from the French-speaking campaigns, just because that's like also for the CPC campaigns, the only thing which really divides, or where, like on French-speaking websites, only French advertisements are shown, and the same for the German. So therefore, we don't want to learn actually that there are French and German campaigns in the end, but we want to see whether there are other factors where the creatives or campaigns share in common. So the approach here was to use this field-aware factorization machines, which were quite good for CTR predictions, and generating then the vectors for each of those creatives. And what I show you down here is like if we reduce it to like 3 dimensions, I only plotted like 3 areas. The first one is the green ones, where we have different car producers. Then we have the blue ones, which are different bank companies, and the red ones, which are tobacco companies. And as you can see, like, well, for tobacco companies, they're like a little bit over the place. However, we can see that the car industry, and then you see from the shape of the points that it's different brands, that they are more or less together. And also, if we reduce the dimensions a little bit differently, here we can see that now the square markers are the car companies, and we have those here, which are the banks. Different colors are different brands in the end, that they seem to, that there is some clustering, or that there's some fields where they are. However, it's not yet that awesome, so we're definitely looking forward to using the same approaches which we already have for our recommender systems to find similar users and so on, to merge it with this data to see how much we can improve actually the model to predict like which ads are actually clicked or are interesting for similar users, to then expand this whole approach and serve ads to users which are meaningful for them in the end. So that's the current approach we are having there, and wanted to give you this overview of what is currently live, where we are heading to, and there's definitely some time for questions or discussions.